Addition and subtraction of mixed numbers. I'd like to begin this lesson by looking at two mixed numbers and placing them on the number line. A mixed number is a number that is made up of a whole number and a fraction. So let's look at these two mixed numbers. I'd like to start with the number 3 4/5. 3 is my whole number, 4/5 is my fractional part. I'd like to place that on the number line. I have my number lines divided into equal units. I may choose any point to represent 0. I'll choose this point to represent 0, and then I'll label 1, 2, 3, 4, 5, 6, 7, 8, and of course this would represent the integer -1. If I want to place 3 4/5 on the number line, I go to the whole number 3, and then I imagine that I can divide from 3 to 4 into 5 equal units. And notice 1, 2, 3, 4, 5. When I say 4/5, then I need to move 4 of those equal units. Each of those small units is called a fifth. So from 3 we'll go 1/5, 2/5, 3/5, 4/5. So this is the point on the number line that represents the mixed number 3 4/5. Now, the other mixed number that I would like for us to place on the number line is the number 2 9/5. Well, I'm going to label my points the same. I'll start with -1 and then 0. Now for this mixed number, I have a whole number 2 and a fractional part 9/5. Well, let's find the whole number 2 on the number line. And now I need to add to this 2, or I need to move to the right 9/5 units. Well, let's take this first distance from 2 to 3 and divide that into 5 equal units. So I've got 1, 2, 3, 4, 5. Once again, each of those smaller units is called a fifth, but I don't need just 5, do I? I need 9. So let's go on from 3 to 4 and divide that into 5 equal units. 1, 2, 3, 4, 5. Okay, so I have my intervals that measure a distance of 1 divided into equal units. Each of those units is a fifth, so I start at my 2, and then I need to move 9/5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you notice anything? What about these 2 points? They are at the same place on the number line, aren't they? Why is that? That's because 3 4/5 is the same number as 2 9/5. That's why they are at the same point on the number line. Now, in our work with the addition and subtraction of mixed numbers, generally we are going to be adding the fractions to the fractions and the whole numbers to the whole numbers, or subtracting the fractions from the fractions and the whole numbers from the whole numbers. When we add, sometimes we get answers like 2 9/5. Notice this fraction 9/5. 9/5 is improper. We do not want to leave our answers as mixed numbers that are made up of whole numbers and improper fractions. So when we have an answer that is made up of a whole number and an improper fraction, we will need to convert it to its equivalent number that is a whole number and a proper fraction. Remember, an improper fraction is a fraction whose numerator is equal to or greater than the denominator. Just a quick review. How do we change 2 9/5 to its equivalent number of 3 4/5? We take the 5, the denominator, we divide it into 9, the numerator. It goes one time. 1 times 5 is 5. When we subtract, we get 4. We write the remainder 4 over the denominator 5. So this number represents the number 2 plus 1 4/5. And look at your number line. Isn't that what we did? We had the number 2, and then we went one whole unit, which was 5/5 plus 4/5. So we know that 2 plus 1 gives us 3, and then we have the 4/5. So let me emphasize that if we have an answer where we have a whole number and an improper fraction, then we want to convert the improper fraction to its equivalent mixed number. I would like to say also, though, that there are times when we have 3 4/5 and we want to write it as 2 9/5, particularly when we are subtracting mixed numbers and we need to borrow. But we will talk about that a little more later on in the lesson. Okay, hopefully we have an understanding of a mixed number and the different forms that it can be written in. I'd like for us now to add and subtract some problems, and basically what I want you to remember is that we add the fractions to the fractions and the whole numbers to the whole numbers. We subtract the fractions from the fractions, and we subtract the whole numbers from the whole numbers. The only thing we'll really need to check at first will be to make sure that our answers that are mixed numbers do not contain improper fractions and that they're reduced. So let's look at some problems here. In problem number 1, actually, we are adding a whole number to a mixed number. When we add a whole number to a mixed number, we add the whole numbers. 7 plus 5 is 12, and then we write the fraction 2/3. Let's make sure that 2/3 is reduced and it is not improper. I would also like to say that all of these problems can be written vertically and worked as well as horizontally. And I will try to work them both ways. Different teachers will explain it different ways, and so I'll work it both ways for you. Let's look at problem number 2. Remember, I want to add the fractions to the fractions and the whole numbers to the whole numbers. When I get ready to add the fractions, of course they have to have the same denominator. In this case, they do. I'll say 5/8 plus 7/8. That will give me a fractional part of 12/8. Now let's add the whole numbers. 5 plus 3 will give me 8. Now let's check this fractional part. It can be reduced, and it's improper, isn't it? Well, let's convert the fact that it's improper first. Let's divide the 8 into the 12. It goes one time. When we multiply and then subtract, we have a remainder of 4. Let's write the 4 over the 8. So we have the whole number 8, and we want to add to that 12/8 written as its equivalent mixed number, which is 1 4/8. So let's add the whole number to the whole number. 8 plus 1 is 9, and let's write the fractional part 4/8. Let's reduce the 4/8. 4 and 8 have a common factor of 4, so let's divide both the numerator and the denominator by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Let's look at problem number 3. In problem number 3, the operation is subtraction. We'll subtract the fraction from the fraction and the whole number from the whole number. In subtraction, it is important to look at your mixed number that comes first. Always when we say we subtract the fraction from the fraction, we take the fraction in the first mixed number and subtract from it the fraction in the second mixed number. Of course, they have to have the same denominator, and they do. So we'll say 11/12 subtract 7/12, which will give us 4/12. And of course, with the whole numbers, we take the whole number in the first mixed number and subtract from it the whole number in the second mixed number. So we say 3 subtract 1 is 2. Now let's check the answer. Is 4/12 improper? No, it is not. Is it reduced? No, it is not reduced, so we need to reduce it. 4 and 12 have a common factor of 4. 4 divided by 4 is 1, and 12 divided by 4 is 3. So we want to write the mixed number 2 and 4/12 as the mixed number 2 and 1/3. Let's look at problem number 4. I think just for a change, let's write it and subtract it vertically. We have the mixed number 5 and 3/5 subtract, and in this case it is a whole number 4. Well, there's no fractional part to subtract. We've got 3/5 subtract 0, and we know that a number subtract 0 just gives us the same number we started with. 3/5 subtract 0 is 3/5, and then on the whole number, 5 subtract 4 is 1. Now let's check the 3/5. 3/5 is a proper fraction, and it is reduced. That gives us some experience adding and subtracting whole numbers and mixed numbers, and adding and subtracting mixed numbers where the denominators are the same. But what if the denominators are not the same? Well, we know that we cannot subtract or add fractions unless the denominators are the same. So what we will have to do if the fractional parts do not have a common denominator is to find a common denominator. Of course, that common denominator will be the LCM, or the least common multiple, of the denominators. We'll use the least common multiple as the LCD, or the least common denominator. I would like to go through the rules for adding and subtracting when the denominators of the fractional parts are different. We'll start with the rules for adding mixed numbers. To add mixed numbers, we write the fractional parts as equivalent fractions with a common denominator if that is necessary. Number 2, we add the fractions, then we add the whole numbers, and last we write the answer in simplest form. And that means that the fractional part should not be improper. The fractional part should be a proper fraction, and it should be reduced. The numerator and the denominator should not have any common factors except 1. Actually, the rules for subtracting mixed numbers when we do not need to borrow are basically the same. Let's look at those. To subtract mixed numbers without borrowing, first we write the fractional parts as equivalent fractions with a common denominator. Next, we subtract the fractions, then we subtract the whole numbers, and last we write the answer in simplest form. Okay, let's work some problems where the fractional parts will not have the same denominator, so we'll need to find equivalent fractions for our fractions. Let's look at problem number 5. In problem number 5, we are adding 2 and 11/12 to 5 and 7/15. What we'd like to do is to go ahead and add the fractional part to the fractional part, but we cannot since those denominators are not the same. So we need to find equivalent fractions for our fractions. To do that, we want to find the LCM. To find the LCM, let's write the 12 as a product of its prime factors. 2 times 2 times 3, or 2 squared times 3. And let's write the 15 as 3 times 5. So our least common multiple in this case would be 2 squared times 3 times 5. Now let's figure out what number that equals. 2 squared is 4, 4 times 3 is 12, 12 times 5 is 60. So we want to rewrite each of our fractions with the denominator of 60. Let's write the 2 and 11 twelfths. 12 goes into 65 times, so we know we want to multiply the 11 and the 12 by 5, plus the 5 and 7/15. Let's find an equivalent fraction for 7/15. 15 goes into 64 times, so let's multiply by 4 over 4. We'll have 2 and 11 times 5 is 55. 12 times 5 is 60. Plus 5 and 7 times 4 is 28. 15 times 4 is 60. Now look at what we've done. We've found equivalent fractions for our fractions. 11 twelfths is equivalent to 55 sixtieths. 7/15 is equivalent to 28 sixtieths. Since I have done that, now I may add my fractions. When I say 55 sixtieths plus 28 sixtieths, I need to add my numerators. When I add 55 and 28, 5 plus 8 gives me 13. 1 plus 5 gives me 6. 6 plus 2 gives me 8. So I write my sum of 83 over my common denominator of 60. I have added my fractions. Now I add my whole numbers. 2 plus 5 gives me 7. Now, I look at 83 sixtieths. It's improper, so I need to find its equivalent mixed number. Let's divide the 60 into the 83. It goes one time. I multiply and then subtract. 3 subtract 0 is 3. 8 subtract 6 is 2. I get a remainder of 23. Let's write the 23 over the 60. So my mixed number is 1 and 23 sixtieths. So I have 7 plus 1 and 23 sixtieths, since 1 and 23 sixtieths is equivalent to 83 sixtieths. Combining these, I have 7 plus 1 is 8, and I write my fractional part of 23 sixtieths. Now, is 23 sixtieths reduced? And the answer is yes, it is. So my answer here is 8 and 23 sixtieths. Let's look at problem number 6. I think I'll work problem number 6 vertically just for a change. Let's write the 9 and 3/4. Let's subtract from it the 4 and 3/8. Notice when I write these vertically that I line up my fractions and my whole numbers. What I would like to do is to say 3/4 subtract 3/8, subtract my fraction parts. But in this case, since my denominators are not the same, I can't do that yet. I need to find a common denominator and write equivalent fractions. Well, my 4 goes into my 8 evenly, and anytime my smaller denominator divides into my larger denominator evenly, I know that I'll use that larger denominator for my LCM. So my least common multiple in this case is 8, which I'll use for my least common denominator. For my 9 and 3/4, I want to write an equivalent fraction for 3/4. 4 goes into 8 2 times, so I know that I want to multiply my 3 and my 4 by 2. So I'll have 9 and 3 times 2 is 6 over 4 times 2 is 8. So 9 and 6/8 is equivalent to 9 and 3/4. Now, since my 3/8 already has a denominator of 8, I do not need to find an equivalent fraction for 3/8. So let's write the minus 4 and 3/8. Now, my fractions have the same denominator, so I may subtract. I say 6/8 subtract 3/8, which gives me 3/8, and 9 subtract 4, which gives me 5. 3/8 is a proper fraction, and it is reduced. Notice each time that I subtract that I take the fraction in the first mixed number and I subtract from it the fraction in the second mixed number. Just like with the whole numbers, I take the whole number in the first mixed number and subtract from it the whole number in the second mixed number. Now, have you noticed that in our subtraction, each time that I have subtracted, the fraction in the first mixed number has been larger than the fraction in the second mixed number? Let's look back at problem number 6. Notice 6/8 is larger than 3/8. Now, do you think that's always going to be true? Do you think that the fraction in the first mixed number is always going to be larger than the fraction in the second mixed number? No, it is not. So what will we need to do if the fraction in the first mixed number is not larger than the fraction in the second mixed number? What do you think we'll do? What do we have to do when we are subtracting whole numbers? We have to borrow. That's right. So that's what we're going to do. If the fraction in the first mixed number is smaller than the fraction in the second mixed number when we're subtracting, we will borrow from the whole number of the mixed number. I'd like to work some problems where we need to borrow, but before I do, I'd like to review the ways that we can write the one that we will need to borrow. If I wrote the fraction 4/4, what number would 4/4 equal? 4/4 is 1, or we can think of using the meaning of division for fractions. 4 divided by 4 is 1. What about 5/5 or 5 divided by 5? It's 1 also, isn't it? What about 100 hundredths? 100 hundredths equals 1. We know that any number divided by itself is equal to 1. A divided by A is equal to 1 as long as A does not equal to 0, because we know that division by 0 is not defined. Well, let's carry this one step further. What number would 2 and 4/4 equal? Well, if 4/4 is 1, this would represent the number 2 plus 1, or 3. So 2 and 4/4 would be another way to write 3. Well, could I write 3 as 2 and 5/5? What's the answer? Well, 5/5 is 1. That would mean 2 plus 1, or 3. Yes, I could write 3 as 2 and 5/5. So how do we know how to write the 1? Well, let's look at some problems. Let's look at problems 7 and 8, and I think then we'll know how to write the 1 that we'll need to borrow. I'd like to begin with problem number 7. With problem number 7, actually we have a whole number, and we are subtracting from that whole number a mixed number. Let's look at that. I have 7 subtract 4 and 2/5. Well, What I would like to do is to take the fractional part of the first number and subtract from it the fractional part of the second number. It's just that I don't have a fractional part for the first number, do I? So what I'm going to have to do is to borrow one from the 7. I'm going to think of 7 as 6 plus 1. I'm going to write the one that I borrowed as, I'll use the denominator of this other fraction. Since this denominator is 5, I'm going to write my 1 as 5/5. 6 and 5/5 means 6 plus 1, which is equal to 7. And then I want to subtract from it 4 and 2/5. And the reason I wrote my 1 as 5/5 was because I know that I want to subtract these fractions. And in order to subtract fractions, I have to have the same denominator. So I choose whatever the denominator is of this second fraction to be the denominator in the one that I borrowed. And I know that to write the one that I borrowed, I have to have the same numerator and denominator. So I'll write 5/5. Now let's subtract. Fraction subtract fraction. 5/5 subtract 2/5 gives me 3/5. And now whole number subtract whole number. 6 subtract 4 gives me 2. 3/5 is reduced. So my answer here is 2 and 3/5. Let's look at problem number 8. I'm going to work 8 vertically. Let's write 5 and 4/7. Subtract 3 and 6/7. I would like to subtract my fractional parts. I have 4/7, subtract 6/7. Notice the fraction in my first mixed number is smaller than the fraction in my second mixed number. 4/7 is smaller than 6/7. So that tells me that I want to borrow. I want to borrow one from my whole number 5. I'll write my whole number 5 as 4 plus 1. So I have a 4. And how do I want to write the 1? Well, look at my denominators. They are 7s, aren't they? So I want to write my 1 as 7/7. The 4 and 7/7 means the same as 4 plus 1, which is equal to 5. So I've represented the 5. Now I need to add the 4/7 to it. So I have 4 and 7/7 plus 4/7 is 11/7. I'd like for us to look at this on the number line. We have taken 5 and 4/7, and we have said that that is the same as 4 and 11/7. Well, let's put both of these numbers on the number line. On the 5 and 4/7, I mark 0, 1, 2, 3, 4, 5, 6. My 5 would be right here, 5 units from 0. I now need to mark my 4/7. I take my unit from 5 to 6 and divide it into 7 equal intervals. I want to go over 4 of those. So that's where 5 and 4/7 would be placed on the number line. Let's look at 4 and 11/7. Let's mark 0, 1, 2, 3, 4, 5, 6. Of course, we go to our 4, and then we need to move 11/7 to the right. Well, my unit of 1 from 4 to 5, since my denominator is 7, I know I want to divide it into 7 equal intervals. I need to move 11/7. This only is 7, isn't it? 1, 2, 3, 4, 5, 6, 7. So I need to go 4 more. So I need to divide from 5 to 6 into 7 equal intervals. So let's see, from the 4, let's move 11 sevenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice where it is. 4 and 11 sevenths. 4, and there would be 4. And then that represents my 11 sevenths, where from 4 to 5 is 7 sevenths, and then I move 4 more sevenths. All right, let's complete our problem. I just think it's very important that you understand why we can write 5 and 4 sevenths as 4 and 11 sevenths. Let's see here. We now have 4 and 11 sevenths. We want to subtract from that 3 and 6 sevenths. Notice by borrowing the 1 and rewriting it and adding the 1 as 7 sevenths to our fraction 4 sevenths, now our fractional part in our first mixed number is greater than the fractional part in our second mixed number. So we may say 11 sevenths subtract 6 sevenths, that is 5 sevenths. And now let's subtract our whole numbers. 4 subtract 3 is 1. 5 sevenths is reduced. So that is our answer. Now notice in problems 7 and 8. In problem 7, I only had one fraction. In problem 8, I had 2 fractions, but they had the same denominator. We will not always have the same denominator, will we? So if we don't have the same denominator, it will be necessary for us to rewrite our fractions as equivalent fractions. Actually, when we're subtracting and the denominators are not the same, sometimes we can't tell if the fraction for the first mixed number is greater than or smaller than the fraction for the second mixed number until we write it as an equivalent fraction. After we write those equivalent fractions, then we can determine whether we're going to need to borrow or not. What I'd like to do now, though, is to go through the list of steps that we'll need to use when we need to write the fractions as equivalent fractions because they don't have the same denominator, and then we discover that we're going to have to borrow because the fraction in the first mixed number is smaller than the fraction in the second mixed number. Let's look at those steps. To subtract mixed numbers when borrowing is necessary, first we'll write the fractional parts as equivalent fractions with a common denominator if they do not already have a common denominator. Our next step is to subtract the fractions. However, if the first fraction is smaller than the second fraction, we know that we need to borrow. So let's go over the steps that we will use to borrow. In order to subtract the fractions, we will borrow 1 from the whole number of the first mixed number. Then we'll write the 1 as a fraction with the same denominator as in the equivalent fractions of the mixed numbers. Next, we'll add the 1 to the equivalent fractional part of the first mixed number. Then we'll be able to subtract the fractions. After we subtract the fractions, we'll subtract the whole numbers. And after we subtract the whole numbers, we'll make sure that the answer is in simplest form. Okay, I think we're ready to work a subtraction problem where we'll have to first change the fractions to equivalent fractions with the same denominator, and then we'll discover that we need to borrow. I'd like to apologize for the technical difficulties that we're experiencing with the camera when I work the problems. Hopefully this is not too distracting to you as you try to learn this lesson. Now let's look at problem number 9. In problem number 9, we are to perform the indicated operation. We have 4 and 5/6, subtract 1 and 7/8. We know that we would like to subtract the fractions. We cannot because the denominators are not the same, so our first step will be to rewrite the fractions as equivalent fractions with a common denominator that is equal to the LCM. So let's find the LCM. Let's factor 6 into its primes. We get 2 times 3. Let's factor 8 into its primes. 8 is 2 times 2 times 2, which is 2 cubed. The LCM is equal to the 2 cubed times the 3. 2 cubed is 8. 8 times 3 is 24. So we'll use 24 for our common denominator. Now let's rewrite each of these fractions. We have 4 and 5/6. 6 goes into 24 4 times, so I want to multiply the 5 and the 6 by 4. Subtract 1 and 7/8. 8 goes into 24 3 times, so I want to multiply the 7 and the 8 by 3. We have 4. 5 times 4 is 20 as our numerator. 6 times 4 is 24 as our denominator. Subtract 1. 7 times 3 is 21 over 8 times 3 is 24. Now, I would like to say 20 24 subtract 21 24s. My first fraction is smaller than my second fraction, so I will need to borrow from my 4. I will think of this 4 as 3 plus 1. I will write it as 3, and I will write the 1 as 24 24s because 24 is my common denominator. 24 24s is 1. 1 plus 3 is 4. So I have written an expression for my 4, 3 and 24 24s, and now I need to add to it the fractional part of this mixed number, 20 24s, and then I have subtract 1 and 21 24s. So I have 3. Adding 24 24s to 20 24s, I get 44 over my common denominator of 24. Subtract 1 and 21 over 24. So what I have done is I have taken 4 and 20 24s and I have rewritten it as an equivalent mixed number, which is 3 and 44 24s. Now my fraction in my first mixed number is larger than my fraction in my second mixed number, so I may subtract the fractions. I say 44, subtract 21, and I get 23 for my numerator of my fraction over my common denominator 24. I say 3 subtract 1, and I get 2 for my whole number. So the answer here is 2 and 23 24s, and 23 24s cannot be reduced. Okay, I guess maybe you're ready to try some problems now. I'd like for you to work problems 10 through 13. I'll put them on the screen. Please pause your tape, copy the problems, work them. I'll give you some time and then I will work the problems. At this time though, I'll look at these problems. Okay, how did you do? Let's take a look at these problems. Let's start with problem number 10. In problem number 10, the indicated operation is addition. We want to add our fractions to our fractions, and we may because they have a common denominator. So let's say 3/4 plus 3/4. We get 6/4. Let's add our whole numbers. 4 plus 5 gives us 9. Now let's look at 6/4. 6/4 is improper. Let's divide the 4 into the 6. It goes once. 1 times 4 is 4. When we subtract 4 from 6, we get 2. So 6/4 is equal to 1 and 2/4. So let's say 9 plus 1 and 2/4. 9 plus 1 gives us 10. And let's write our fraction, 2/4. 2/4 can be reduced. Let's divide by 2. So we have 10, and 2 divided by 2 is 1. 4 divided by 2 is 2. So our answer here is 10 1/2. Always when you're adding mixed numbers, be on the lookout in your answer for your fraction to possibly be an improper fraction. Usually when we subtract, in our answer we won't have an improper fraction, but when we add, it's very possible for that fraction to be improper, and we know we don't want to leave our answer like that. In problem number 11, I think that I'll work it vertically just for a change. Let's see here. We have 5 1/3. We want to add to that 3 4/5. We'd like to add our fractions to our fractions, but since they don't have the same denominator, we know we're going to have to find the common denominator, which will equal to the least common multiple. So let's see, the 3 is a prime factor, the 5 is a prime factor. Anytime that our denominators are prime factors, then the LCM is equal to the product of those prime factors. So our LCM in this case is 15. 3 will go into 15 5 times. So let's multiply by 5/5. 5 will go into 15 3 times. So let's multiply by 3/3. For our first mixed number, we'll have 5 and 1 times 5 over 3 times 5. For our second mixed number, we'll have 3. 4 times 3 or 12 over 5 times 3 or 15. Our fractions now have the same denominator, so we may add them. 5/15 plus 12/15 will give us 17/15. 5 plus 3 will give us 8. What about the fractional part of this sum? The fractional part is improper, isn't it? Let's divide the 15 into the 17. We get 1. Let's multiply and then subtract. We have a remainder of 2. So we'll have 1 and 2/15. So we'll have 8 plus 1 and 2/15. 8 plus 1 will give us a whole number of 9, and our fraction is 2/15. 2/15 is reduced. So the answer to number 11 is 9 2/15. For problem number 12, the indicated operation is subtraction. We have the whole number 5. We are subtracting the mixed number 2 7/10. The whole number 5 does not have a fractional part, so we will need to rewrite it as 4 plus 1. We want to borrow 1 from that 5. We'll write that 5 as 4. And how do we need to write this 1? Since this denominator is a 10, we want to write that 1 that we borrowed as 10 tenths. 10 tenths is 1. 1 plus 4 gives us 5. So 4 and 10 tenths is equivalent to 5. We want to subtract from that 2 and 7 tenths. The fraction in the first number is larger than the fraction in the second number, so we may subtract. 10 tenths subtract 7 tenths gives us 3 tenths. 4 subtract 2 will give us 2. The 3 tenths is reduced, so our answer in problem number 12 is 2 and 3 tenths. In problem number 13, the indicated operation is subtraction. We have 5 and 2 ninths, subtract 4 and 5/6. Now, when these fractions have different denominators, sometimes it's hard to tell which fraction is larger. However, since we have to write them as equivalent fractions, after we have written them as equivalent fractions, it's very obvious which fraction is larger. In this case, you may know which fraction is larger. I want to work this problem vertically. Let's write that 5 and 2 ninths, and we want to subtract from it the 4 and 5/6. Remember, if you choose to work these vertically, you line your fractions under your fractions and your whole numbers under your whole numbers. We want to rewrite the fractions as equivalent fractions, so we need to find the least common multiple. The 9 factors as 3 times 3, or 3 squared. The 6 factors as 2 times 3. The LCM in this case would equal 2 times the 3 squared. The 3 squared is 9. 9 times 2 is 18. So we'll use 18 for the LCM. I would like to say that anytime you're working with these fractions, if you can look at it and figure out what the LCM is, you don't need to go through this process. I just go through this process for those of you who maybe are still having some difficulty in finding the common denominator. All right, 9 will go into 18 twice, so I want to multiply the 2 and the 9 by 2. 6 will go into 18 3 times, so I want to multiply the 5 and the 6 by 3. Now let's see what I have here. I'll have my 5. 2 times 2 will give me a 4 in this numerator. 9 times 2 gives me an 18. Subtract, I'll have my whole number 4. 5 times 3 will give me 15. Over 6 times 3 will give me 18. So my first step in this problem is to rewrite these two fractions as equivalent fractions with the same denominator. After I have rewritten those fractions, it is very obvious whether I need to borrow or not. Since this first fraction, 4/18, is smaller than the second fraction, 15/18, and since I'm subtracting, then I know I want to borrow from the 5. Sometimes it's kind of hard to tell which of these two fractions is larger until you've written your fractions as equivalent fractions. But after you've written them as equivalent fractions, then you should know whether you need to borrow or not. Let's, since we do need to borrow, let's borrow from this 5. We're going to think of this 5 as 4 plus 1. We're going to write that 5 as 4. We'll write the 1 as, since our common denominator is 18, we'll write that 1 as 18/18. The 4 and 18/18 represents the 5. 5 is the same as 4 and 18/18. And then we need to add the 4/18 to that. Now I don't really need to do anything to the second mixed number, so I'm going to just leave it alone for right now. But I do want to figure out what 4 and 18/18 is and 4/18 and I'll write it down here. I have that whole number of 4, and 18/18 plus 4/18 will give me a numerator of 22 over the common denominator of 18. So I have rewritten this equivalent mixed number 5 and 4/18 as 4 and 22/18. And now I'll write that second mixed number 4 and 15/18. Now, since my fraction in my first mixed number is larger than my fraction in my second mixed number, I may subtract. 22/18 subtract 15/18 gives me 7/18. On my whole numbers, 4 subtract 4 gives me 0, and I don't need to write the 0. So my answer to problem number 13 is 7/18. 7/18 is reduced. I hope you were very successful in working those problems. This completes the addition and subtraction of mixed numbers lesson. Once again, I would like to apologize to you for the technical difficulties. Please rewind the tape before you return it. Thank you.